Welcome and welcome to Cambridge Chemistry channel. You are required to subscribe the channel and like the video. Today I will discuss the qualitative analysis of paper 16, question paper 3-6. At each stage of first read out the instructions very carefully. At each stage of any test you are to record details of the following: color change seen, the formation of any precipitate, and the solubility of such precipitates in an excess of the reagent added. Where gases are released, they should be identified by a test described in the appropriate place in your observations. You should indicate clearly at what stage in a test change occurs. No additional test for the ions present should be attempted. If any solution is warm, boiling tube must be used instead of test tube. Rinse and reuse test tubes and boiling tubes where possible. Where reagents are selected for use in a test, the name of the correct formula of the element or compound must be given. If you don't know the formula, write down the name of the compound. It is better. Fb4 and Fb5 are aqueous solutions of equal concentration in mole per dm cube. Each contains an anions and one cations. The cation is the same. Cation is same. This is very important to know. The cation is the same in both Fb4 and Fb5. Half fill. This is the preparation of Tollens reagent. Heat the water to about 80 degrees centigrade and then turn off the Bunsen burner. This is the hot water bath needed in the test below. To about 2 cm depth of aqueous silver nitrate in a test tube, add a few drops of aqueous sodium hydroxide, silver nitrate, then aqueous sodium hydroxide to give a grey brown precipitate. Then add aqueous ammonia dropwise until the precipitate just disappears. This solution is Tollens reagent and is needed in a test below. Carry out the test on a separate sample of Fb4 and Fb5. So it is very important to mark the test tube with Fb4 with marker and Fb5. So this is very important to identify the test afterwards. Test and observation, Fb4 and Fb5 for recording the result. So mark with the marker on your test tube which you are taking Fb4 and Fb5. To a 1 cm depth of solution in a test tube rack, add a spatula measure of sodium carbonate. If gas is evolved, because sodium carbonate to 1 cm depth of solution. If gas is evolved, so definitely will be carbon dioxide gas. Yeah, observation physis turns lime water milky. In Fb5 the same observation, physis or effervescence you can write down of carbon dioxide turns lime water milky when it passes through lime water. So when you add to a 1 cm depth of solution in a test tube, add a few drops of acidified potassium magnet, place the test tube in a hot water bath. Then place the test tube in the hot water bath. The solution first turns purple to, because solution of acidified potassium magnet is purple to pale yellow, pale solution, and then colorless, no reaction. And in this you can observe the gas, the rate of gas evolved. So if there are less effervescence, so write down less effervescence, or identify the rate of reaction if both FB4 and FB5 have same observation. So identify the difference between the two observations. So if, for example, I have less bubbles of gas in FB4 and more bubbles of gas, more fizzing, write down also. So no reaction to a 1 cm depth of Tolan reagent in a test tube, add few drops of solution, place the test tube in the hot water bath and leaves for several minutes. So after several minutes it will turn silver, can be gray, can be, and black. PPT is produced. So no reaction over here, or little white precipitate can be. Or white PPTs can be. From your observation in 1, identify the cation present in both FB4 and FB5. Keep it in mind that over here it is written that the cation is the same in both FB4 and FB5, and you know that if the same observation for test 1 is there and sodium carbonate will react with FB4 and FB5, and if carbon dioxide is released in both FB4 and FB5, then it must be acid. So the cations in FB4 and FB5 must be H positive. From your observation in 1, what can be deduced about the anion present in FB4? So anions present in the FB4. If this is less bubbles of gas and more bubbles of gas, so it means FB4 would be weak acid. So this is weak, can be weak acid, and it turns red litmus. It turns Tolan reagents when you add few drops of solution. Place the test tube in the hot water bath in Tolan reagent, 1 cm depth of Tolan reagent, and when you add FB4 in this and silver grey precipitates, so it must be aldehyde or weak acid, methanoic acid. So the ion is this ion, or can be, because methanoic acid, it can be further oxidized. So by using potassium manganate. So, and this is the aldehyde group, so it can be oxidized. Place 1 cm depth of FB4 and FB5 separately in 2 test tubes. Measure and record the temperature of the 2 solutions. If FB4 is obviously weak acid and FB5 is strong acid, then FB4 has low temperature than FB5. So you measure and record the temperature accordingly, and keep it in mind that FB4 has low temperature, should be low, and high temperature. To each solution, add an approximately 2 cm length of magnesium ribbon. Measure and record the maximum temperature reached in test tube. So, Fb4 plus magnesium, write down the temperature over here, and Fb5, and keep it in mind Fb4 is a weak acid and temperature would be definitely low, and it will be strong acid. Explain why there is a difference in the temperature rise for the reactions of magnesium with solution Fb4, as Fb4 is weak acid, partially dissociates and have slow reaction. While Fb5 is strong acid, fully ionized, and have fast reaction or more bubbles of gas, hydrogen gas. So hopefully you got it. Thank you for watching.